How's everybody doing? Welcome back to the Math 140 video lecture series. Today we're going to look at kind of an extension of, or some more applications of linear equations, specifically mixing problems. And in general, it's when we have two equations that we have to consider. So let's see how that comes about. Recall in the beginning we talked about in the medical field about the understand how various quantities change with time in respect to some other quantity. For instance, if you have two solutions, one with 10% concentration, another with 30% concentration, but you need a solution with 25% concentration, how much of each do you need? You need to understand the way the concentration changes as you mix the two solutions together. Now, it seems pretty complicated, but we really can model this very well with lines. So let's see how we're going to do that. I wrote down some of the specific information that we need from this problem. We have some, just think of it as a huge bottle of, or a container of 10% concentration of, let's suppose it's saline, all right, a saline concentration, and 30% of, and then another container with 30% saline concentration. What do I mean by concentration? It means if there's 10%, means 10% of the number of liters of liquid that's there is salt. That's what I mean by 10% concentration, all right? Now let's say we want to mix together those two in order to get a 25% concentration, and I added this to be 100 liters. I need 100 liters of that 25% concentration. All right, so how can we do this? Well, let's think about how these quantities relate to each other. Well, in order to do that, we want to start with defining our variables. And how do I get them? Well, the question is, how much of each one should I mix together? How many liters of each one? So we'll let X be liters of 10% concentration, and Y be liters of 30% concentration. All right, so now how do these interact? Well, that 100 liters there, right, that tells me that the liters of the 10% concentration plus the liters of the Y concentration equal 100. All right. Now this is a nice relationship between X and Y. However, it doesn't tell us how much we need of each yet. We just know that whatever X is, Y is 100 minus X liters, right? So we need a little more information in that, well, we haven't used the concentration. So let's say the liters of saline in for X liters of water is 0.1 times X, or of the solution. And similarly, there's 0.3 Y times Y, right? 30% of the liters of 30% solution. That's considered that of, we use a lot of times as multiplication. So 0.3 times Y, that equals, well, it has to equal what we have on the other side. It's 25% of 100 liters. That's what we're looking for, right? So maybe we want to rewrite these a little simpler. We have X plus Y equals 100. Gesundheit to myself. And 0.1 X plus 0.3 Y equals 0.25 times 100 is 25. Now, how do we solve? By the way, before we go to that, always go to Desmos, graph it, look down that left-hand corner, see what they look like. X plus Y equal to 100, and 0.1 times X plus 0.3 times Y equals 25. Those are our two. That's visually. And what are we looking at? We want something that satisfies both of these, which is, of course, our intersection there. Looks like that's 25, 75. We'll see how to find that algebraically over here. So I would use substitution. And use equation 1 to solve for y. So y equals 100 minus x. And then substitute that in for y there in equation number 2. And so we have 0.1x plus 0.3 times 100 minus x equals 25. All right. Now it's an one equation, one variable. We could solve this. I'm going to 0.3 times 100 is 30. And so we have 0.1x minus 0.3x plus plus 30. Right? That's 0.3 times negative x is my negative 0.3x equals 25. We get negative 0.2. X equals negative 5. When I divide both sides by negative 0.2, which is really multiplying both sides by negative 5, I want you to think about why that's the case, or use a calculator as well. That's fine. So X equals 25. And what is that? That's 25 liters of 10% solution. Similarly, all right. Well, we still need y. How much of y is there? Okay, we get y is 75, and that's liters of 30% solution. And we mix those together, and we'd end up with our 100 liters of 25% solution. And do notice that you can get that 25 and 35. You hover over the intersection of the two lines, and you can find that to check your solution. Make sure you did your algebra correctly. And that's how we do mixing problems. Those are mostly what we're going to do. This approach really solves things in general, something like this: x plus y equal to 4 and x minus y equal to 6. The MRI example was also similar in the beginning when we found where the cost equaled the revenue, right? The number of that was also finding where two lines intersect, and it's similar to that, except for here we've got to put one of them in. For this system, I'll quickly do it as algebraically. Well, I'm going to use substitution. This tells me y equals 4 minus x. I take that, I plug it in for my y, minus parentheses, don't forget the parentheses here, equals 6. And that gives me 2x minus 4 equals 6. And finally, that tells me that, 2x equals 10, so x equals 5. When I plug that back into this guy here, I get y equals negative 1. Let's graph those and see if that tracks. I double check x plus y equal to 4 and x minus y equal to 6. Okay. Oh, I think we're looking good there. Yep, 5, negative 1. That's where those two things intersect. And what it is, it's the one point that satisfies both these equations here. All right, I go and try the Edfinity homework now on more applications of linear equations. Most of them are mixing problems. I think there's one perimeter problem. Perimeter, then we set up a system of equations from it. Hopefully those go well, and please let me know if you have any questions as you go along.